think we're good. So the stream should be coming up now. Hello again, everyone. Hopefully this is working. I believe we should be good, but my camera's, oh no, there we go. Cool, yep, all right, wonderful. So, yep, I guess I just did a good run through of what's happening here. For anyone who is watching this back later on, this is a working session where I'm hoping to just do some Jogglebot work. This is the first one of these that I have separated from the update videos. And yeah, I'm curious to know what you all think about this format. So having them split up will hopefully make it easier for people watching back later, where they can kind of pick and choose exactly what they want to watch. But it will create more videos, more notifications and stuff. So if you have any thoughts on this sort of format or anything related to it, please let me know. But for now, we have a special guest. We have Jon Beno, who has been working very, very hard on his own Jogglebot hand mechanism and has been super helpful with figuring out the design and the mechanics of this throwing mechanism. So I will bring Jon in now. Hopefully you can see us both. Let me get rid of my camera there. Oh, that's annoying. How can I fix that? That's annoying. Because I want me. Oh, okay. I'm gonna have to do two. All right. Maybe I'll just make you big, and then can I make your screen large, or can I get rid of my screen? Actually, I'll just, if I turn off my camera, that should work. And then you'll be able to see me in the corner. That kind of works for now. It's not the worst. All right, cool. So hopefully everyone can hear Jon now as well, and we should be good. So hello, Jon. Thank you for joining.
Yeah, hello. Nice to finally chat with you in person.
Yeah, it's good. It's very, very nice to put a face to a name. I was telling my partner last night that I've seen your fingers in a couple of images, but that's about the detail that I know you to.
Yeah, there's a person on the other end. It's not an alien or a robot.
Yes, it's very good to see. Oh, and you've got a bamboo in the background as well. I'm jealous.
I sure do. Highly recommend.
Yeah, I'm very, very close to upgrading from my Prusa Mark III to a bamboo. I just need a bit more space. It's the eternal problem, space and money.
Indeed.
Cool. So actually, so maybe to start us off, I'm curious to know if you have any thoughts about this friction problem that I was just talking about in the stream, because I've noticed your hand platform has a capstan drive as well, and you were saying that you have done some trial runs with getting yours throwing and catching. And I'm curious to know if you've experienced any slippage on your spool.
It does, but very little. And I can talk to that a little bit. Should I introduce myself a little bit?
Sure, yeah. It'd be very good to know who you are, yeah.
I guess who I am. I'm Jon. I am a aerospace engineer with 15 years of experience now. And I do flight control actuation on electric vertical takeoff and landing aircraft. So I do that for my day job, but my background is in robotics. I worked in a robotics lab doing bits of walking robots back when I was in grad school, Case Western Reserve University. So we did some cool biologically inspired cockroaches and dogs. I didn't do a whole one, but I did some pieces of it while I was there, and an autonomous lawnmower. So this is the sort of background that got me going in robots and stuff. And now I use it for, I guess, more mundane actuators and things that are safety critical and still kind of fun in their own way, but a lot of the detailed design stuff. So it's very cool. This caught my interest as I think this stuff is fun. I've been looking for a project to play and try to it's fun to push stuff hard and break things. Stuff
unless it's too expensive.
Not too expensive, and drone motors and bits of 3D printed. This is hits a spot of this is cool, and say my motivation is to help you any way that I can to make Jugglebot successful. So like bits
Thank
that I
you.
can improve the design and solve the problems. Yeah, I don't know. It'd be fun to say I was part of it and getting it there.
Yeah, yeah. I super appreciate this. Yeah, very cool.
All right. So back to the hand. Should I give you a quick tour of the test bed and then I can hit
I
go?
would love to see it.
Okay. Should I show CAD or do you want to just see the real thing?
I mean, whatever you think is best. I don't know how it's all set up.
It's a little bit of a mess.
The real
Let me
thing
see.
is always cool.
It's
Always
a little bit
special.
hard. You know, I can't. Can you see?
Yep.
How is that?
What is that ball you're using? It looks like a tomato.
Yes, and it squishes every time. So these are, that's a good place to start. This is just a juggling ball that I got from Amazon.
Nice.
It is 130 grams. I know you said yours is a little heavier. And I
Yeah,
think you're using rubber ball.
150, yeah.
But yours bounce a little bit?
They're very firm. They don't really, they squish a little bit. I mean, it's quite cold right now, so they're a little bit less pliable than they often are. And they do bounce, but not much. Like I can show you
Damped.
on, oh, maybe you
Okay.
can't. I'm not gonna be able to show you super easily.
Well,
I can show the stream as well, but they don't really bounce very much.
That's
a little bit.
That's good. They're like nice and spherical and round and rubber.
Yes, the sphericality is useful, I think, but that's
I think so.
something other.
Well, I'll say the thing that caught my eye about like a beanbag is this thing is like super dead damped. I think it helps catching it. But I don't know. I was just curious why you're why that and not an alternative.
My big interest with having a spherical ball is that for a while, and I'm still considering doing this, I have been toying with the idea of having what I've been calling a laser gate that will run. It's basically having a laser across the diameter of the output of the hand, and that laser would be received by a photodiode, and then when the ball passes through, we can calculate, like measure how quickly the ball is actually moving. And so my intention of using spherical balls is that it will mean that I'll be able to get a bit more data on how the ball is actually moving in reality compared to what we expect it to be doing based on just like open loop stuff. It's possible that the throwing will be precise. Like if we can get the hand mechanism to be ideal, then it should be just throwing at the speed that we're predicting it will be throwing at. In which case, using a damped kind of like the ball that you've got might be better. But yeah, I'm not sure. That was the idea behind that anyway. But I do have other balls that are a bit more similar to your ones. They're a bit looser than that, but they have a similar level of like deadening when they fall. And I can pretty easily just change over to those if I need to.
Wow. I guess we'll see how it goes. I mean, that's kind of like part. Now we have a test bed. We can like try stuff and see what it takes to help make it better. And this hand was totally like I drew something very quickly. It's like flatter than yours. It doesn't really come.
Yeah.
I think. And I was thinking like you don't want like a rim to have it like careen out to the side, but that was as much as I thought about it. I think that's an area we can tweak on. But
I mean, to be honest, actually, just on that note, the cup part of the hand that I'm using right now is actually extremely good at keeping the ball in it. Like I've been very, I don't know, lax with like how I can like throw the ball. I don't know if you can see the stream view from what you've got set up right now, but hopefully the people watching from home can. Like it can tolerate a lot of like misalignment, and it will like land back in the cup part. So that aspect is actually quite good and makes me less, I don't know, motivated to have a deadening ball, because that just sits in there so nicely. And as long as the hand can have the compliance that we need, I feel like that should be okay, but that's a big if.
Okay. So get on with the tour. So this is a linear guide. This is like CNC machine tools use these, 3D printers, high-end 3D printers use them. It's a pretty small one, 9mm or size 9. I don't know. It's pretty tiny, but plenty big for this. I think you could even go smaller. 20mm square aluminum extrusion. The top guide, it's been the CAD maybe in a little bit, but the it has a jack screw in the top, so you can loosen these. These are just holding it with friction, and then you can jack this whole thing up. There's a thread in the back. So that, this is like a guitar string, so you can keep tension. It doesn't need to be that tight. It needs to be sort of like when you're throwing, it's like, say, I don't know, what numbers, like 100 newtons of force or something like that. You need to maintain tail tension on the spool so that it doesn't slip. So it's kind of get that differential across the spool. But the tighter you go, it will like multiply and help the tail friction so the spool doesn't slip. I guess high level, and we'll get into the weeds in a second. So there's a spool just like what you showed. What I have right now is 3 wraps around a cylindrical 3D printed spool. And I'm using Dyneema, which is about 150 kilogram breaking strength. It's like 1.2, 1.3 millimeters in diameter. So it's a little bit bigger than what I think we need, but it gives you a little more stiffness. And I don't know, there's pros and cons. So we could probably go smaller, but it gives it a lot of stiffness as well, like along the axis of actuation. So I used it. I have some smaller stuff, so we can play with this and see what works. But this is kind of working pretty well right now. It only has 3 wraps, and it's like not enough for what you would predict with the capstan equation. Like you could do more, and it really helps. Like another wrap gets you quite a bit more friction. So I wanted to see if this would slip. There's a bunch of ways to make it better. You kind of outlined some in the previous stream, like tying it in the middle certainly. But a lot of things is going to make that spool longer. The V groove is another. So I think there's a handful of ways to try and make it better, or use something that's not Dyneema, which would be less slippery. But if this doesn't slip, that has a lot of promise for
definitely
working, and we can tweak it a little bit.
Like the slipping is maybe a good backup as well. Like if things hit the end stops with too much force, then maybe having the slipping will be useful there because it will stop other things from breaking. But I don't know if that's worth the annoyance that the slipping otherwise introduces.
Yeah, on end stops. Things crashing into end stops is almost always bad and almost always breaks things. It's kind of hard to make it not bad. So you can kind of try to absorb the energy, but it's always a little bit tricky to actually do with all the energy that's in the motor spinning really fast. It's going to kind of break something. What I have is I put a little block on here that I just torqued a little bit. So it'll at least give like 10 millimeters of travel to like suck up a little bit of energy. And
is that similar to how like a soft close draw works?
The stop?
Yeah.
It's all it is a block with a single fastener, and there's like friction that you get from the tension of the fastener. So it would take, like, we could calibrate this so that torque on the fastener gives you some amount of force to get the slide, and you can give yourself a little bit of over travel.
Right, and that slides in the aluminum extrusion, does it?
Yeah, exactly.
Right.
So
it
absorbs some energy, but like honestly, if the spring is the thing that the string is the thing that breaks, or one of the 3D printed plastic parts, like I don't know, it's probably not the worst thing.
What you can do about that.
I don't, like you said in a couple of streams back, like I don't know what would break first in this. Like it's pretty long, and like if you want as hard as to break the string, I feel like something's gonna give. But
it's a bit of a nerve-wracking thought experiment to think like, if this did really just go haywire, what would actually break? I don't like thinking about that too much.
Let's see. The motor's in the middle. This was a bit of an epiphany for me. I'm going to kind of talk about this for a second. So originally I was trying to follow your design a little bit more and stick the motor down on the bottom. With this design with a single loop, it wants to kind of go on the lower back pulley. The issue is what you're running into is the angle of the string trying to get from the pulley that's right next to it to the spool doesn't really work very well. So you need it to be able to kind of slide back and forth. So putting it
Yeah,
up in
you
the
want
middle
that distance to be a lot
gives
bigger.
you your 200 millimeters or something, and it's like totally not a problem with this design. So the spool could be like twice as long, and it would work. I know this troubles you from a symmetry perspective, but I do think it solves the problem of the length of the spool quite well.
To maybe just back myself up a little bit there, the symmetry is I tend to be wrapping a lot of things in my like symmetry complaints a bit, and one of the issues that I have with this in particular, having the motor in the middle, is that there's not really a good spot to mount it on the frame that I have here, because this is only being supported by the rest of the robot at the top and at the very bottom with strings. So it has to be attached onto here, and there's not really a good spot because that, like, the hand will it would be hard to fit that somewhere where the hand won't collide with it. And the fact that there are like the two sets of strings are perpendicular to each other, I think that would make for some complicated routing to have I think that's where the symmetry part of things comes into it, because having the strings be perpendicular, having it the motor in the middle at the bottom is nice and symmetric. Like it is perfectly. It's like if you drew planes between the pairs of strings, the axis of the motor is like right at the intersection point of those two planes, but there's nowhere else we can have the motor so that that's true, if that makes sense. Yeah.
Right.
But if I did change over to a linear guide like what you've got, then we wouldn't need all four strings, and then it might become a lot more simple. Yeah. So
yeah,
the linear guides.
So
are very
I
tempting.
think you could do something like your hand. Like you obviously need to add structure. You need to like add some nodes in the middle of that from out where you're attaching the Stewart platform to the actuators. Like just need to provide the attachment point in the like mid-span to that. There might be a way to do it without like totally changing much about the way the platform is set up. That's kind of what I was thinking, but I don't know. It kind of depends on the direction you want to go with the overall hand design.
Yep.
Which, before we do that, should we do a demo?
I would love to see a demo.
Or a demo? Okay. Let's see if I can make this work. It's a little awkward for me having my laptop pointing over here because usually I'm sitting over there. All right. So first, we'll do a throw, and all this is doing is just a hard position step up and down. So there's nothing too clever about like the trajectory generation or anything like that of the throw.
So you're using only filtered position control?
It's filtered position control. It's actually not filtered, it's passed through, because I just want it to go as hard as possible for right now. And I want to kind of see what it can do. And the way that I'm throttling it is by like the size of the step that I'm going up. So I'm going up, I don't know, say 50% of the travel you'll see. And it's enough that it doesn't hit the ceiling, which hopefully is exciting. All right, let's see if it works. There you go.
Oh, so cool. That is
so
cool.
It catches, even with the ball that I have, kind of jumps down like a quarter of an inch or something.
I kind of missed that. Did the hand move down before the ball hit it, or did the ball force it to move down?
The ball forced it to move down. I'll do it again.
Nice. Oh, your hand was right away there.
10 millimeters or something. It's dropping after, and it's a solid thud and it catches. But now my thought on this is that it's hitting it so hard that you get this big impulse of tension in the string that I think it's enough that it's going to start inchworming its way along the spool. Yeah. So you do want to be careful with controlling how hard it's hitting the hand. And there's either like you kind of want to accelerate the hand down to catch, or do something that's damp. So now I'll do my other demo, where it does the same thing, but then goes up to the damped catching mode, and this is pretty cool. So it does the same throw, goes halfway back up, and all that is the position gain is 0, the integrator is 0 on the velocity loop, and the velocity gain is reduced. So it's just saying sit in this position, and the energy that it puts in, it's damping out using the velocity gain only. And there's enough friction that it actually stops moving. If there was no friction in the system, it would kind of drift down to the bottom, but it's enough that it actually stops. So we did something like this, and that's the reason to make the hand like transparent with low impedance.
Low enough.
So like, and even like if you don't have the motor controller on, it does a pretty good job of doing this. It just kind of like accelerates.
Yeah, I've noticed that as well. Like I can just like chuck the ball in, and it has
it's
got such a nice like absorption of the energy.
It does a pretty good job of catching the ball. So I feel like I was not as optimistic about the size of this motor, but I think you did a pretty good job of picking one that's like just about right.
Just enough.
I think it has the performance to throw the ball. And what I did, like I can easily throw like 2 meters, and I think it'll throw maybe 3, but my ceiling's in the way.
Wow.
But I can
3 meters.
Yeah.
3 meters is pretty good. That's super high. That's like nearing on like
in my head, I had a stretch goal for 10 meters. Is like the hardware should be capable of throwing 10 meters hard open loop throw.
I agree in the long term, but I'm skeptical that these motors will be able to do that.
Yeah, this motor won't. A little bit bigger motor could. But
yeah, well, I mean, the plan, like I hope to be able to bring Jugglebot to the point where it can beat the world record of 14 balls. And according to my juggling book, 14 balls is like, actually, let me just grab it. Oh, I've got a cable. 14 balls requires a throw height of 12.9 meters for humans.
Yeah, just for enough time to catch and throw.
Yeah. But I mean, if the precision is greater than human ability, then we can definitely bring that down a bit. Like this is saying like 5 balls is 1.2 meters, but like I can definitely do 5 balls at lower than 1.2 meters. It's all about precision.
Yeah, exactly.
Yeah. But yeah, 10 meters is definitely on the cards at some point.
All right. Well, that's kind of had that in my head, so that kind of gets you to the scale of like the speed of the drive and what it needs to do.
Yeah, I'm expecting though to change a bit about this design to accommodate that 10 meter throw height. Like I'm expecting to need to increase the stroke length of the hand by a fair bit, and potentially,
maybe not by much.
You don't think so? 30 centimeter stroke length. Okay. Yeah, I mean, I'm definitely very much in like hobbyist level of motor control, like understanding. Like I've done very little, and I've looked at some videos of like industrial motors, and I'm like, oh my god, these motors are so powerful. So maybe I just need to get my hands on some really beefy ones, and then I'll feel a bit more confident about short stroke length, high throws. Yeah,
but I don't know. Like the thing that's going to happen, you have to be a little bit careful with going big, is you might start adding inertia. So like the small motor, it depends on how it optimizes the like torque to inertia ratio. Yeah. I don't really like this is an outrunner. It has more inertia than the equivalent kind of torque motor if it was inside out, the magnets from the inside. So that's already kind of given up some. But I don't know. I think this is plenty that this will work. You'll be able to get this to juggle. I think the only thing you might run into is duty cycle, where the motor's going to get hot. And
well, I've got 10 of them, so if they break, I can swap them out.
Yeah, you could just replace it. But the performance starts rolling off as it gets hot, so and that kind of runs away quickly. So we'll see. I mean, one of the things I think I'll do with this is to like run the test repeatedly and get the temperature of the stator as it's going through that, and see how long it can go before you should be worried. But it might just do reasonably well and get you a minute or so.
Yeah, I mean, honestly, like 100 catches is pretty good. Like I just need to, for this iteration, like for this motors and everything, I'm happy if it can become YouTube, like if it can work to a YouTube level of standards where I can have it run for like a couple, like enough to get like a nice clean shot, and then I can transition to a different shot just before the motor dies. So as long as I can get like a couple decent length shots for like a fancy like stuff made here style video, then I'm totally happy with these motors. Obviously for like long term, like if I want to have this running for like days on end, I'm very much expecting to need to change motors for that, but that's a problem for later.
Yeah. Okay. So I guess thoughts on design and direction a little bit.
Yeah, I'm all ears.
So like I picked the linear guide. I started with trying to make like a track roller thing with rollers. Without trying to copy your design, I was just trying to, think through like, what does this thing need to do?
Mm-hmm.
And do that maybe on the aluminum extrusion just to get something going quickly. And part of the reason I'm attracted to the linear guide is it has very good lateral control and moment stiffness of the hand.
Yeah.
So as the platform is swinging around, I think you're going to have like more than a G, probably several G of swinging the Stewart platform around once you're like going at speed and mid-span with no, so the ball's kind of in the middle so the ball's moving up and down and then the platform's moving, like that thing's going to wobble around.
It definitely does. But I'm very in two minds about this. This feels like it could be a useful thing because when it's down the bottom, it has very little wiggle room, and same thing at the top, it's got very little. It's only as it approaches the middle, it's got more and more. So I'm thinking during the process, like it comes in, ball comes in, it lands, this moves around, and maybe this is a bit naive, but I'm hoping that having the hand have a little bit of lateral play will allow it to kind of like match the momentum of the ball a little bit better. And then once it's down the bottom, it's going to be like fully, maybe it still has a bit more than I would like down the bottom there. But once it's down the bottom, should stay pretty much exactly where it is. And then when it goes to throw again, it'll kind of like come into the ideal position. I don't know, it's very like hand wavy about this right now, but for now, I want to try this. I want to try this with the lateral movement and just see how well it works. So I'm hesitant to swap to a linear guide rail before trying this in the proper juggling pattern. But if the guide rail is necessary to get the hand to work in the first place, then obviously that's like, if it needs to be done, then it needs to be done. But yeah. I'm very, I don't know, intrigued by how this will work. I fully expect in like 6 months I might be looking back on this and be like, this was obviously a stupid idea and it obviously won't work, but it's not obvious to me right now. So we'll see.
Totally fair.
But you are absolutely right that like the linear rail will completely remove that.
Now, maybe you don't need a linear rail. So with your hand design, I think, so you can get the lateral control with some rollers along the 3 carbon tubes.
One slight problem with that. These tubes are not straight. They are tapered a little bit, which does make it a little bit annoying. I could straighten them out, but that would require like changing these around.
Are they like golf club kind of tubes, or are they
fiber.
But why are they? Where's the taper?
Sorry, I mean tapered is in like the diameter of where they attach up here is slightly larger than the diameter down the bottom.
Okay, they taper it to get it off the mold.
No, like the tubes themselves are perfectly cylindrical, I hope.
Oh, the tube's cylindrical, but you have it.
The angle of them is like, that would be straight-ish.
Okay.
So they're on an angle like that. I could change that, but to be honest, I don't really remember why I did that. I think it was just so that it provided, like previously when there were more strings, it kind of made like a funnel to keep the ball in. And like when it was down the bottom, it was fully surrounded by like rods that were quite close to it and strings that were also quite close to it. So like there was no way that the ball could even roll out. So even like doing super aggressive movements, the ball would still stay in. And then having it open at the top means that there's like a larger catchment area so that the ball can kind of like be a little bit off but still kind of roll in. But yeah, I mean, with all of the changes that are happening, I don't think that tapering is fully necessary. Yeah. Yeah, sorry to interrupt.
Okay, no worries. Yeah, I think the other piece of that is So the strings that you have two up and two down, and they're like 90 degrees apart.
Mhm.
And they're like, I think that's probably like the bare minimum to give you some moment stiffness of the hand.
Yep.
But I think if you, what I'm picturing, and this is, I haven't done this yet, but I could do a layout showing what I'm thinking, is something like the continuous loop that I have on my prototype, but instead you loop it up and down 3 times. And then in the middle, it attaches to the hand. So as you rotate a single spool, single capstan spool, the hand goes up and down, and then you have a return string that goes over to the next string. It's actually very similar to what you have in your current hand design.
Can you see
to the next.
Can you see the string view now?
I can. I wiggle stuff around, and there's a little bit of lag, so it's tripping me up, but I got it. Yeah. So this is my crazy picture trying to get this down in not very much effort. So like you need to come up and over a pulley to attach to the hand, and then on the near side it attaches to the hand in a different point. So you can think of that as like 3 individual strings that all terminate at the hand, or one continuous loop, and you have to make an attachment to the hand with some kind of inch point or a fastener or something like you're doing. But then somewhere along this line, you can put the capstan, and this should get you both up and down control at 3 or 4 nodes if you wanted. I think 3 would be enough.
Yeah.
And this kind of integrates into your current hand design pretty well.
Yeah, I do agree that more attachment points would be good. This is definitely the bare minimum. But yeah, I'm curious. I definitely don't fully understand this. If you do CAD this up, I would love to see that, because I think having a 2D, like I was thinking last night about how I would draw this up in 2D. Like if someone asked me to just sketch this so that they can understand how it works, it's so hard to like translate this into 2 dimensions. So I feel like this drawing that you've done possibly suffers from the same dimensional issues, where it's just really hard to like translate from 2D into 3D.
Yeah, definitely. This is trying to do like a 2D flat schematic of it. It could work 2 points on the hand, but obviously it's going to swivel along those 2 points, and that wouldn't work. So you need at least 3.
Yeah.
But yeah, so I think in the spirit of trying to get your current hand working, I think you could basically take that structure that you have, figure out where to put the pulleys and route the string, and then one of those pulleys could be the capstan, but like I said before, I really think putting it in the middle of a long span of one of those strings that are looping down becomes the natural place to put it.
It definitely helps with having allowing the wraps to slide along the spool.
Yeah.
But it's so geometrically annoying. There's no natural spot for that to go.
Yes.
Yeah. Okay. All right. That's very interesting. Do you have any particular thoughts about the Synchromesh? Do you have any, I don't know, do you have any experience with it or anything?
I do have some thoughts. So I guess I'll start with the capstan drive, or like a belt drive, or like 2 really like standard off the shelf options that it can go as fast as you want, like no question. The Synchromesh cables that I was scrolling around looking at some of those, they're rated for sort of like a meter per second continuous operation, maybe 2. It gives me a little bit of concern that it's gonna jump in and out of the guide.
Yeah, that's one of the reasons why I'm keen to use the smaller Synchromesh, is because the larger one, like it can't even bend that tightly around. Like I wouldn't be able to get it around that small spool. So that's pretty much a non-starter there. And even the smaller one, like I do have to kind of pull it a bit tight. But I'm hoping that if there's enough tension in the line, then that should keep it on. But yeah, there's a lot of acceleration going on here, so maybe you're right.
Yeah, the reason you want that is because you don't want it to slip. So with the capstan, you can solve that with a few more wraps and a little more tension. If you can pre-tension it and it's like a nice stiff structure where it's not springing and like I guess you can tension it up nice, then that's gonna get you pretty good tension control. And then obviously, like you've been saying in the stream, you can't have it wrap over itself and maintain good tension control. Like the string does have a little bit of elasticity, but you really want the string tension to stay constant with really any of these systems.
Yeah, especially the Synchromesh, because the effective diameter of the Synchromesh is like double what it appears to be because of the outer wrap. Yeah.
And I don't think it's going to go around a tight spool, like you say, very well for very long. So that's where like the capstan's really nice because you can go around a pretty tiny shaft. Like you could just about go around the motor shaft at 5 millimeters diameter and make that a capstan drive. It's not optimal; it's too small, but I mean, it's capable of that. So you can get a lot of gear ratio right off the bat, which is a big advantage of it. Now, the belt is not as flexible on like the pulley size, but there's a 16 millimeter or 16 tooth pulley that's like easily available, and it's like 10 millimeters, I think, about in diameter. So it's not so far off what we're doing with the motor. I don't know if it would work with this motor, but that like if part of picking a motor and like going with a belt, like if you went with the linear rail and a belt, it's like such a slam dunk. Like you could, if you're really big enough, you could throw the thing easily 10 meters, probably higher.
Yeah, there's definitely something to be said for like the tried and tested things. And I mean, all of the developments in the 3D printer space has definitely shown that belts can do a lot. Although there are some printers that use the Synchromesh and they do seem quite performant as well. I'm just worried about the changing angles. Like there would have to be at least one 45-degree turn for the belt. And the belt...
Well, the belt really wants to be on a linear guide, I think.
Yeah.
So you have basically my test stand, one loop up and around, you attach it to the hand, and that's what makes it like, it's really simple, and it would get the job done really well.
Yeah, and relating to the advantage that I spoke to at the end of the last stream on how open this is, that actually might even be better, because if I had the linear rail along one of these tubes, all of like the belt and everything would be along that tube as well, and then this entire, like both of the other sides, or all three of the other sides will be completely open. That definitely has some appeal to it.
As I think about one or two of these things juggling, like having open 270 degrees or more on one side, I can really see that being an advantage.
Yeah, so I haven't mentioned this, I don't think, at all, but I actually have, I can just reach with my cable. Oh. Hang on, let me take my headphones off. I have some linear guides, and this one actually just slipped out, so I'm not going to use that one. But I do have some, but they're not quite long enough for the whole span of, I mean, I guess I can show you the rail just slipped off, but like it's a bit too short. So I think I would definitely need a longer one, but maybe I should just go with this. Can the motor be down the bottom still? I guess I can still have the motor down the bottom, but just like turn it sideways. Yeah, I don't know. For a little while, I've been thinking in the back of my mind that like the linear rail is the end solution here, but I don't know. Part of me doesn't like it, and I just need to like come to terms with why that is. I don't know. I guess, I mean, it sounds like you feel the similar thing. Linear rail is superior.
It's a bigger tear up of the platform design, but I mean, I think it's a pretty good answer. And if it was like too expensive, like I could see that. But honestly, like part of the reason I did it on my platform, I was like, wow, I can get this on Amazon for like 30 or 35 bucks. I don't know. It's a 400 millimeter length
These are definitely not the most
are, and
expensive
it's
things in
This
Jugglebot.
is what's that?
These would definitely not be the most expensive things in Jugglebot.
Yeah, exactly. So like, I mean, like higher end ones, like these used to be very expensive, and higher end ones are, but you can get these pretty reasonably priced, and they're like in stock at Amazon. So
Yeah.
might be a good answer, but we have to like come up with the structure of the platform to make that work. Like what to attach it to. I don't know if the aluminum rail is the right answer. It's certainly a quick answer,
I
but
think
like it doesn't.
ideally the linear rail will be long enough that it can perfectly terminate in, like, I could hold it in the printed part at the top and have the other end supported down the bottom and just have it like directly next to the carbon, like the relevant carbon fiber tube, just like that. Oh, I do like that.
Yeah, I think you kind of want to
have to be straight.
Make like an open V on one side, so you still have your 3 nodes out to the steward platform, but you kind of want the hand to like stick out on one side of that. So you need, that central post. I mean, it might as well be a 2020 aluminum extrusion to start, just because it's easy, and you do need a little bit of stiffness on the rail. The rail by itself, I think you bend a little bit, but
I think, to be honest, I would probably stick with the general structure here. I think I would have to straighten these tubes, at least the one that the linear rail's on. Actually, no, I wouldn't. I can just print the hand so that it's got that. No, I think I would straighten it out so that the linear rail goes perfectly vertically. But I think that this structure is quite stiff, and I think it would be stiff enough to have all of this be supported well.
do you need the 3 carbon tubes in the center if you put the rail in the center?
If the rail is in the center.
Yeah.
But then where will
That's
the ball
kind of
be?
what I'm picturing is
But
the
the
ball, it's cantilevered off to the side.
I don't know. I'm fond of having the ball be smack bang in the middle of this structure. That seems like it would make the kinematics simpler.
Okay, so you could still offset, so the hand can be in the center, like where you catch the ball. The rail can be offset, but that aluminum rail can still be what connects the top node to the bottom node of your steward platform.
Yeah, up here, like spanning these two.
I think so. I don't know. I think so I'm gonna have to wrap it up here in a few, but I think, in terms of like brainstorming on design and which direction we want to go, like I could help playing CAD a little bit, either with the continuous capstan drive spool, at least do a quick layout of that, or could help propose some ideas for how to do the linear rail, kind of depending on what you thought was more interesting.
Yeah. I'm very, very torn right now. There's like the three big ideas now of having capstan with Synchromesh. I still have faith that will be better at least than this, versus having all the strings terminate in the spool. That feels like the easiest option right now, but it doesn't feel like a very good long-term solution. I don't like how the spool length would have to just continuously increase as the stroke length increased, and it just seems like more opportunities for things to go wrong, like if the string starts bundling up on itself and that sort of thing, versus the final solution of having the linear rail, which definitely seems like the best, but it will be the most work from where we are right now. It's always the way, isn't it? The best solution is the hardest.
This is a very common problem that sometimes you know you need to fix it, but you keep trying to band-aid it, and it's like at some point you kind of lose sight of the fact that if you had just fixed it, it would have been fixed. So,
yeah.
But I don't know, like there's something to be said for you've got something that's pretty good, pretty close. Pick the things that are the biggest hitters to try and improve, and then see how far you can get. Yeah.
Okay. Well, very, very much appreciate your time, Jon. This
Yeah,
has been.
think about it.
I definitely will. I think I need to immediately pick up some more linear rails. And I just remember having a hard time. I don't know if anyone watching is like knows where to buy linear rails in Australia. Please let me know, because I had a bit of a look on Amazon and eBay and that sort of thing, but I could only find them in very specific lengths. And to do what I'm imagining I would want to do, I want a very, very specific length to like match this perfectly. And if it's too much longer, it's going to look crap because it's just going to be like sticking out the end. And if it's too short, then that's obviously killing the stroke.
Yeah, I use an MG9H, I believe, car and a 400 millimeter stroke.
That
Which
would
I
be
think
good.
so what you're
400 mil. Yeah.
No, it's
Also,
actually
just with
rail, so it's a little bit less than that on the stroke.
sorry, say again.
400 millimeters the rail length is, and then the car has
Yeah.
to stay inside of the rail. So
Yeah, so the effective length is a bit less. Yeah, that might be
I
good.
don't think it's that far off from what you're doing. That's why I picked that one.
Yeah, that's very close. So right now, I believe I've got around 350 mil from absolute bottom to absolute top, and yeah, that seems to be working well. But yeah, just to explore the aluminium extrusion versus carbon fiber tubes, I'm hesitant to make this structure heavier than it needs to be. I want to kind of keep this as light as possible, because as you said, like the steel platform is going to be whipping this around, and having this lighter, I suspect, will be helpful with doing those sorts of quick movements.
Always better. Yeah, so that's definitely true. And maybe there's something that's not the aluminum rail, like some composite tube or something, and we put inserts along its length to attach the rail that would be lighter to get that done.
Yeah, having like the mounting on the extrusion is definitely a lot simpler than on the tubes. That aspect is good. Yeah, all right. Lots and lots to think about for sure. It's frustrating. Always the final 20% always takes the longest. But we'll get there.
All right. But yeah, I agree. You convinced me. I'll do a quick layout. You shared the step file of the platform. I'll route the string in the way that I'm picturing, and maybe that's the right answer for the near term to get you juggling, and then maybe there's an upgrade later. But this is, I think, would be good enough to get it
honestly,
working.
If this can do 3 balls in one hand, I will be so stoked. And according to Burkhard Polster, that requires 1.9 meter through height. So we can go 1.9, I'm happy. Anything bigger than that, I am fully expecting to need to make some changes. So we'll see. Just need to get the slip. Yeah. Anyway, thank you very, very much. For anyone who's watching, I'm going to keep the stream going because I want to do some stuff after the call with Jon. But yeah, thank you super, super, super much. I very much appreciate this.
Yeah, definitely. It's been fun. Look forward to keep working on it.
Cool. Thank you, Jon. Enjoy the rest of your evening.
Yeah, you too. Take care.
Cool. Okay. That was super interesting. I hope you all agree. All right. So to address some comments that have come up through this, Josh Dotson says, I like the Synchromesh. I try it with FDM first. I think it could work just fine. This is what I want to do now. So I'll get to this in a sec. And I'm not going to synapsomorphy. I was thinking resin SLA would be a great application for that. I agree. Last night I was reminiscing how much easier this process would be if I had an SLA printer. I could just print it myself. Just click print, deal with the fucking hazardous chemicals, and then have my print. But I do not have an SLA printer, so I'm thinking it might be worth getting this made by, I don't know, some printing mob in Melbourne. I'm sure there are some around. I'm considering it. Yeah. And you've also said, have you thought about some static string ball guide for the hand? Are you referring to having like strings running down from up here down to here that just kind of sit there? Because if so, I have not thought about that, but I have thought of having sheets. So if I could have like a, I don't know, like a thin metal or something light, a sheet that runs down here with like, I don't know, if I really wanted to get fancy, I could like line it with like a PTFE sheet so that it's really non-slip. I have considered that, and I am not doing that now because for one thing, it feels like it's just adding too much complexity in a way that I don't know that I need it. And also because I want, my default position on a lot of these parts is that I want to make them as open and visible as possible. I want someone who hasn't seen Jugglebot before to be able to walk up to the robot and like see it in action, or like see it just sitting there and be able to like follow everything and kind of see where everything goes. Whether or not it's understandable is a different thing. Like understanding this capstan drive and how this string is routed is a little bit not obvious, I think, at least. But they'll at least be able to like trace it and see where things go. There's not just like a black box where it's like string enters and some magic happens and then another string exits. So I want to try to keep everything as open as possible, and maybe strings actually would potentially be a good way to do that, because then you can still see through the strings. But yeah, probably later. I don't know yet if this will be an issue where there's an opening on the side. So we'll see. Yeah, cool. So I'm thinking, I have a suspicion that Josh might be right with FDM printing might work, because I've had a look around on printables, and I have found some people have modeled some Synchromesh drive pulleys, and this 3.81mm pitch is the same size that I would be considering using if I do go for this. So, and these look like they're FDM printed, like that's definitely FDM printed. The issue is that I don't know how they made this cutout. I don't know what sort of structure they used. And there's another one here with a similar but slightly different design. And these both seem like they work fine, but obviously I need a spool, not just a pulley. So these are not quite what I need. So I'm thinking we can, for the rest of this working session, it probably won't be a super long one, definitely not as long as last week's, but I'm thinking we can I want to try to model the Synchromesh cable such that it goes around the spool in the way that I would want it to. And I had a bit of a quick go of this morning. So if this is the center of the Synchromesh cable, like the gray part, the metal part, then I've found a way to do this second sweep. And my computer may struggle here doing the live stream at the same time, but we'll see how we go. But obviously this is not quite right. Like the wraps around should be a circular cross section rather than this like elliptical business. So I want to try to fix this. And yeah, my thinking is that if we can model the Synchromesh cable accurately enough, then I can just put the spool on the inside and then do like a Boolean remove the Synchromesh cable part, and that should work. But I'm not sure how to model this. So I want to just have a play around with this. So let's get some music going. I can't like shuffle my playlist. Hopefully you can all hear this, it's not too loud. Yeah, and of course, if anyone has any ideas about what John and I were just talking about, I am very, very open to them. I'm honestly feeling more and more sold on the linear rail thing. Part of me has known for a while. Let me get a big screen for this. I've obviously been thinking about linear motion. Let me turn the music up actually while I'm talking. I've been thinking about linear motion for a while, and like since doing the linear actuators like 7 or 8 months ago, I've been considering having a linear rail on these. And there were lots of suggestions in my linear actuator videos being like, why are you going to this much effort when you can just have a linear rail? And I don't regret the way that I've done the linear actuators, but I do think that I've written in my notes, like for the next version of the linear actuators, if there ever is one, linear rails, like that's step 1. And this feels like maybe a good opportunity to integrate them into the robot. But I want to try modeling the Synchromesh cable first. If this works, then we can try printing off some spools with the Synchromesh cutouts. I'm skeptical that I'll be able to print it on my FDM printer, keeping in mind that I currently have on my printer a 0.6mm nozzle, and I do not want to change that. I do have smaller nozzles, but it's just such a pain to change, and I would prefer to not need to do that. So with that limitation in mind, which is maybe a bit of a self-imposed one, I'm skeptical that I'll be able to print. I also actually want to just mention that I have some rubber sheet from McMaster Carr, which is a tricky thing to get in Australia. So I got this rubber sheet, and I'm wondering, along the lines of having the heat shrink lined spool, where we can like mold the Synchromesh form into the heat shrink, I'm wondering if I could have a spool, like so we've got this, we can wrap some rubber around it, and then secure, and then either just have that wrap of rubber and somehow glue that onto the spool or something. Maybe that rubber itself would be enough because it would kind of mold to the form of the Synchromesh, but I'm skeptical that that will be able to stop slipping. Or I can have the rubber and then heat shrink, and then like when I crank it really tight, that should hold the form a bit better. But to be honest, John's mentioning just then of the quoted limits on the Synchromesh speeds made me realize that I actually haven't looked at that in a while. And he does have a very good point that when tension is loaded up on one side of the capstan, the other side is going to be inclined to slip if it's not proportionally tensioned. And if there's like an impulse on the hand, which I'm expecting there to be many of, because that's how I'm expecting the catching to be working, that might cause the whole thing to slip a bit. However, again, on the other hand, I've also noticed that the Synchromesh, when it coils up, I just got to create a little coil here and I'll show you. When it coils next to itself, like if I have multiple wraps in the capstan, the Synchromesh tends to kind of like nestle against itself, and I'm thinking that this will help with keeping it from slipping. So if you can see, hopefully, if I can get it to focus, it's a little bit tricky to show, but the black parts, come on, maybe not. Let me just quickly try this camera. This might work a bit better. Yeah, that's better. So you can see how the black parts of the Synchromesh are like sitting right next to each other. And I think that should help with it slipping, because they'll need to all like skip over the neighboring one. So it would not only need to slip over this spool, but it would also need to slip past each other. So maybe that will help. But we need to have a model of the Synchromesh first. So yeah, let's see if we can get this working. So here is just a helix. I'm actually going to decrease the length of this because SolidWorks struggles as I make that second sweep a bit longer. And the way that I've done this second one, which is now broken for some reason, we've done the classic, if I'm streaming and CAD-ing at the same time, I cannot right click on broken features. Which is very, what does it say? All right, let's just increase this back to what it was. Yeah, the way that I've done this second sweep is by having a circle here that is swept along, and there's this neat feature where you can give it a twist value, and I've given it the maximum twist value that I possibly can, which is 36,000 degrees, and I don't actually think this is perfectly correct. So the Synchromesh cable that I'm using has a 3.8mm pitch, and let's see if we can measure point to point from like here to the equivalent spot on the next one, which is there. Oh, cool, it's actually tighter. That's good. I thought it would be less tight. But anyway, like we can clearly see that this profile is not correct. So I'm thinking I can make a circle in like a perpendicular plane and then sweep that along, and that might help. But let's get some music going. So yeah, I do still want to try this. I want to try the Synchromesh spool. And then maybe by doing that, I can confirm for myself that that will not work. And then we can finally commit to the linear rail, which does seem like the better solution. But let's try this first. So I want plane that goes through here. And I will add a circle onto that. I think the black part, I just kind of measured it with my calipers, which is a little bit tricky, but yeah, it's about 0.8 millimeters. And I want that to be I want it to touch this circle. All right. So I've never really done modeling like this before, and I have no idea if this is going to work, but I want to sweep this around this so that it will spin. I have no idea if this will work. Oh, huh. Holy shit, I was really not expecting this to work. I need to uncheck merge result. One thing that really pisses me off about SolidWorks is like if you accidentally start the wrong thing going, like if you're doing a fillet and it's like, oh, fillet of 10 millimeters, and then you're like, no, I want a fillet of like 1 millimeter. You just have to like wait for it to realize that it can't do it before you can cancel it. That is amazing. I am so surprised that worked. All right, let's see about this pitch. This is the other tricky thing. So in this menu where I'm making this second spiral, I can control, maybe the revolutions is what I want. Yeah, this is what I want. Okay, so let's measure if we measure the length of the helix, then we know the pitch of the secondary spiral, and so we can figure out how many revolutions we should have. So this is 252.55. Let's copy that. And we want to go, what? I didn't even copy. I'll just do it with my calculator. Old fashioned way. 252.55 divided by the pitch is 3.81. Should have 66. Maybe I can actually set that in here. I don't like that it does this as well. Like it just yeets that circle way out to the side. Let's not merge the result. And that was weird. So I have set that to be number of revolutions, but this is still showing the angle. That's annoying. All right, let's just set it to the calculator value, 66.3. Broke. Why? Why? That looks like it's less. Let me check. Feels like there should be a better way to do this so that it's a bit more parametric. But I'm just going to do this manually. 3168. All right, so we need a little bit more. 66 is definitely right, but why can't I do it? Where is the limit? We're literally going to do one off. Why? All right, I'm going to have to go 67. Let's round up a little bit. Be close enough. All right. So that looks more or less circular. I don't know. If anyone can think of a better way to model this, please let me know. So those cross sections look a bit funky. They look very funky. But that's okay. All right, so I have set this with a spool diameter. Did I not set that? All right, I have 8 millimeters, yep. All right, so now we should be able to, we don't need this sweep anymore. Now we should be able to add a spool into the middle. Top plane, extrude boss. That looks cool. Eight millimeters. Let's see what happens. Yeah, I followed the. So thank you for bringing that up. I found like this one and one other one, and they seem to work, but this is more or less what I'm doing. Like I'm twisting it along its path by a certain number of turns, but it doesn't feel like it's. It would be good if I had a bit more control over like the pitch of like how far this is away from here, and I don't know if this approach will allow for that, unless I add some like funky equations in there that do it automatically. Let's go 25 millimeters. I do not want to merge, and I want to intersect these guys. This may take a while. Oh, very helpful error, a geometric condition. Maybe we can combine. Well, that's funky. I think I need to decrease the diameter of my spool. So this is the other tricky thing. It's like, what is the actual like diameter of the, like what is the actual like working diameter of the Synchromesh? I would think it's the center line of the internal gray cable, but I'm not too sure. Let's make that a bit smaller. 7. It's looking a bit better. This is such a weird shape. Let's go a bit smaller. I mean, that looks pretty good. Let's maybe make it a smidgen bigger. Let's see what this looks like when it's trying to print. Where is my folder? Nope. Just opened the wrong thing. It would be great if I could make that like automatically open up, push a slicer. Okay, all right. Those features are large enough to exist. Pretty small though. All right, maybe we should just give this a go. Maybe, hopefully Josh is right and this just works. But I don't know, now that I see this, I'm wondering if that will be deep enough to like stop the synchro. Like the Synchromesh would really have to be wrapped on this to stick. And this, I'm very aware that this is quite different to this design that this person's made, where like even the center line seems to be accounted for. Like the whole thing is kind of sitting inside the spool. Maybe make this a little bit bigger. And actually, because of tolerances, maybe I should make the diameter of the black wrap a bit bigger as well. Why? Why did you fail? I guess 0.8 is my max. Why would that fail if it was larger? Oh, I think it's hitting itself. All right, so I can increase the pitch. That's, the bigger I make this, the longer the spool is going to have to be, which is a big problem. All right, so now we should be able to increase this. All right, let's see what that looks like. Oh, that looks much meatier. All right, cool. I will print this off in PDJ, not PLA, and see how this works. To be honest, oh, Josh, I think you need to cut the center line too. Do you reckon? Let me go back. So you think I should have a cutout? But that, so with the way that I've set this up now, this spool is slightly smaller than the like diameter of the helix. And I think if I make it bigger, then SolidWorks doesn't like that. Oh no, okay, all right, let's try this, and maybe we can do a secondary combine to remove this guy. So the main body is this. Something like that, but with a bit less of a... How can we get rid of that feature? I want to like fillet every single one of those. Let's save before I do anything. This is a sort of operation that can really cause SolidWorks to crash. Let's see, 0.5. So that's probably what I would want. Let's see if this can automatically select. Is that right? Looks right. And now we play the waiting game. Oh, nice. I don't want that one. Don't want that one, that one. on SolidWorks. Although I guess I can't really complain because that just saved me from selecting 300 lines. Make the secondary coil intersect the main coil. True, actually that might make a bit more sense as well because I've increased the diameter of the black wrapping coil, and that actually might make a bit more sense to have them intersect. I just want to see how this looks first because I'm already almost the whole way there. Once this realized, there we go. That looks pretty cool. All right, this actually looks pretty good to me. I'm gonna keep this as one configuration. Let's call this intersecting secondary coil. So this we don't want. And instead we want to modify this sketch. No, not that one. This one. So right now this to here. It's tricky to like do these in a way that the configuration will work. Let's get rid of that. Okay, cool. So now we can set the length of this. Yep, 0.5 in all configurations. And then for this configuration, we want it to be a little bit smaller. 0.3. Maybe 0.4. I guess we only need it to be overlapping a little bit. All right, will this work? It's definitely nicer. But I feel like we would still want to fillet those edges. Maybe we can overlap that a little bit more. I think we would still want the fillets. Take a little while to load, apparently. Yeah, I feel like this is effectively the same thing. Let's see how this prints. That has not worked. I think I broke the 3MF. Every now and then, I've noticed this happens. If I... Oh no, because it saves it. Yep. Never mind. All right. So this should print totally fine. And should fit. This might take a bit of tweaking to get the pitch perfectly correct, because I mean right now I can only... Actually, I guess this will give me much better measurement points. So let's go from here to here. It should be 3.81. It is significantly less. All right, so we need to fix that. Fix that by making the coils more spaced out. Why is this dimension all the way out here? I don't like that they've given me the angle if I want to like edit it in the here, but if I just want to change the number of revolutions, I have to do it in this menu. I want it to be further apart. Let's try that. Yeah, something that kind of like annoys me about the Synchromesh cable is that there's not really very many accessories for it. Like you can buy, there's like a dozen sizes of pulleys, but that's about it. There's no spools, and there's no like, I don't know, there's nothing, like there's not even that many sizes of pulleys. It's just like a couple. Why can't I select that point? There we go. So there, to there. 2.73, still too small. This feels like such a dodgy way to do it. There to there. 136, getting close. It'd be great if I could measure from that menu box. Too far, 4.43. So we want to go like kind of in between, so maybe 35. Say 36. That's pretty close, maybe one more. I guess I can't really, so that was 3.71, so we want it to be further apart, which means, God, 35 might actually be it. Oh, whoops. I wonder how easy this is to do an on-shape. Oh, 3.79, I'm calling that close enough. All right, let's fix the fillet. It works, but has an error. What is it unhappy about? Oh. It's so frustrating that doesn't, I can't edit it. Alright, whatever. It seems to have worked well enough. Maybe I want to increase the size of that just a smidge though. Nope. Maybe Josh's idea of having the intersecting coil might fix this. It looks good, but it still needs that fillet. Let's add it to this configuration. Except I can't edit it. That looks like it should be okay to print. Huh, all of these edges are the same, but it apparently won't work. Even though it did before. The same edges. It's just not showing the preview. It's very uncommon. No. Ah, it's so frustrating. Like it works. Oh, come on. I do not want to have to select these manually. That's the right one. Maybe a little bit smaller. I don't know, these all look the same to me. Maybe it's the end ones. Ah, yes. The ones that are a bit different. We don't like different things. We like everything being the same. Nice, cool. All right, that looks promising. Let's see how this will print. That looks quite good. All right, I think I'm going to give a couple of these a go, and I will report to Zulip on how they go. I'm actually just going to add a hole in the middle so that I can mount this onto a M3 bolt. And I'll probably have to print this with a brim. I had a very fortunate timed print fail the other night when this guy failed like right at the very end of the print, and so it's got a very like cooked top bit, but still works well enough. All right, cool. I am pretty happy with this. I think if anything, if I will ever be able to 3D print the Synchromesh spool, I have faith that this or like this with the very minorly tweaked dimensions would be it. All right, great. So let's pause music, and just as a final, I don't know, what's the word? Decompress after all this. You might have felt that my heart wasn't in this modeling. I mean, the modeling stuff, that was cool. I'm very impressed that worked as easily as it did. But the whole idea of having the Synchromesh, I am unsure of. I'm very much leaning towards the linear rail now, and I'm going to have a good think about how to best integrate this. Because I do agree with John that linear rails are the best way to go. I've always been very put off by the fact that the linear rail would require that there's one attachment point for the hand and that the whole thing is just kind of like cantilevered out from here. That's really kind of irked me, because every time I've done that in the past with anything similar, that cantilever effect just wrecks the stiffness of the whole thing. Like, it means that the part on the end is more likely to bend down. But to be honest, like this, I don't have anything mounted on here right now, so I can't really feel it too well, but this feels very solidly on the linear rail as far as like any movement, any degree of freedom other than just straight up and down feels very tightly constrained. So this feels good. But I just need to think about it. It's ruining the asymmetry, and it's a very, very different approach. Everything's so tricky. But anyway, we are very close. Depending on how these things go, I'm thinking I might model, like do a mock-up design similar to what John has done, where I'm using these linear rails in the current setup, and I'll just like cop the loss of stroke and just have it like up on the side while I'm waiting for the new. If I can find, I'll try today to find some new linear rails that are a bit longer and will fit this stroke a little bit more appropriately. And we'll see how that goes. So close, so close. I've been like moving everything around and just like imagining it in my head, and so close. but I know I've said this a lot. And, yep. But we're getting there. We're getting there. All right, cool. Thank you for joining me, and I hope you found this interesting. And of course, if you have any thoughts about any of this, let me know either in the comments here or on Zulip, particularly this week in reference to the format of these streams. This is a new way of doing things, and yeah, I'm keen to hear your thoughts. So actually, maybe to elaborate on this a little bit and to catch everyone on YouTube up with what we've been talking about on Zulip, I think it could be cool to do a very similar format to what we did today in this working session, where we've got somehow I have a moderated group of people where we can join a live call, like a Google Meet, like what we just had with John, and there can be however many people we've got in there. Ideally, probably just a handful, so it doesn't get too kind of crowded. And then we can stream that call. So that way, like the really dedicated people, the people who are making rigs at home themselves to test these ideas, these sorts of people can be vocally and like video-wise in the stream. And then people who aren't as motivated or aren't as like, I don't know, personally engaged in the project can watch it from the stream and like comment and everything in the comments. And I feel like this format could be a good one because it will mean that the people who are really involved in the project will be able to provide feedback much more easily and in much more detail, like John was today. And then everyone else, like you guys on viewing the stream, can still benefit from that discussion and you can still see exactly what's going on here. I want to try to make this project as open as possible so that people can really easily follow it along. And if you're watching back in like years from now, you can see why all of the decisions were made for all of these steps. And I feel like this is a good way to do that. So, I don't know. Let me know your thoughts. Obviously, there's a lot of questions there around like how to moderate that group and how to make sure it doesn't get out of hand with someone just like taking the reins. If it's something that's not particularly relevant, I can see how that could happen, and I don't really know how to solve that problem. But I'm inclined to give that format a go. I mean, we gave it a go today, and I'm very curious to know your thoughts on how everything went today, and whether or not you'd like to see that same sort of format more in the future with other people as well, other than just John, or more of John, probably. But anyway, yeah, lots of different things going on. We're close, so close. Soon. Soon. All right, thank you for watching along, and thank you, Josh, for your help with this modeling. That was useful. I think that intersecting coil thing is a good idea, and I'm curious to see if the FDM printing works. I'm very curious, but I'll update on Zulip. So if you're curious about how that went, I'll update there, and I'll potentially update in next week's live stream as well. Depends what happens next week. Cool. All right. Thank you, everyone, and have a good rest of the day, and good luck with everything you're doing.